classified on the number of dimensions which are not confined to the nanoscale range. So according to this classification, nanomaterials are four types: zero-dimensional, one-dimensional, two-dimensional, and three-dimensional nanomaterials. Zero-dimensional nanomaterial example is nanoparticles. Nanoparticles, all dimensions are in nanoscale. So no dimension is outside nanoscale. So that is why, because this classification is based on the number of dimensions which are not confined to the nanoscale. So no dimension is confined to the nanoscale. Zero dimension is not confined to the nanoscale. So that is why these type of materials are known as zero-dimensional materials, because their no dimension is outside of nanoscale. Their all dimensions are inside nanoscale. Their diameter is less than or equal to 100 nanometer. One-dimensional materials are like fibers, nanofibers, nanorods. Nanorods or nanofiber diameter is in nanoscale range, but their length is not in nanoscale. Length is greater than nanoscale or greater than 100 nanometer. So their one dimension is outside nanoscale. So that is why these type of materials are known as one-dimensional material. Diameter is less than or equal to 100 nanometer, but their length is greater than 100 nanometer. Length is outside the nanoscale range, and length is one dimension, and so that is why these type of materials are known as one-dimensional material. Two-dimensional materials are like nanosheets, nanofilms, nanocoatings. Nanocoatings, nanosheet thickness is T is for thickness. Thickness is in nanometer range, less than or equal to 100 nanometer. But their length, their width is greater than 100 nanometer, greater than nanometer range. So their two dimensions are greater length and width are two dimensions. Two dimensions are greater than 100 nanometers. So that's why these type of materials are known as two-dimensional nanomaterials. So here is the detail of all the classes. First, we will study about zero-dimensional nanomaterials, material wherein all the dimensions are measured within the nanoscale. X-axis, Y-axis, Z-axis, all dimensions are in nanometer range, and non-dimension or zero dimension are larger than 100 nanometer. The most common representation of zero-dimensional nanomaterials are nanoparticles. So nanoparticles can be amorphous, or they can be crystalline. They may be present in single crystalline phase or in polycrystalline phase. Nanoparticles may be composed of single or multi-chemical elements. They may consist of single element like quantum dots, which are carbon nanoparticles, which are made up of only carbon, and they may be multi-chemical elements. They may have the composition of multi-chemical elements. They exhibit various shapes and forms. They may be in sphere form, or they may be in other forms. Exist individually or incorporated into matrix. Nanoparticles can exist individually and they can be incorporated into the matrix to form the composite. Their nature can be metallic, so they can be ceramic in nature, or they can be polymeric in nature. So next class is one-dimensional nanomaterials. One-dimensional nanomaterials are those nanomaterials whose one dimension is outside the nanoscale, whose one dimension is greater than 100 nanometer, like nanorod, nanofibers, nanotubes. This leads to needle-like shaped nanomaterials. One-dimensional material include nanotubes, nanorods, and nanowires. One-dimensional nanomaterial can be they can be crystalline, amorphous, or amorphous. They can be in the form of single crystalline form or in the form of polycrystalline form. They can be chemically pure, made up of only one element, or they can be made up of more than one element. They can be impure. Standalone material or embedded within another medium. They individually they can exist, and they can be embedded into another medium in the form of composite. They can be metallic, ceramic, and polymeric. Metal, ceramic, and polymers all can form one-dimensional nanomaterials. Two-dimensional nanomaterials like nanosheets, nanofilms. Two of the dimensions are not confined to the nanoscale. Two dimensions, for example, in nanosheets, its thickness is in nanoscale, but its length and its width is not in nanoscale. It is greater than 100 nanometers. So its two dimensions are not confined to nanoscale. So that is why these materials are called 2D nanomaterials. 2D nanomaterial exhibit plate-like shapes, and two-dimensional nanomaterial include nanofilms, nanolayers, and nanocoatings. So thickness is in nanometer range, but other dimensions, two dimensions, are not in nanometer range. Two-dimensional nanomaterial can be amorphous or they may be crystalline. They may be made up of various chemical compositions. They can be used as a single layer or multi-layers. They can be used in different applications. For example, thin layers are used in solar cells. So as a single layer they can be used, as a multi-layer, multiple layer they can be used. These layers are very delicate, so they are deposited on a substrate on a spot, integrated into a surrounding matrix material. They can be present in integrated form in surrounding matrix materials in the form of composites. They may be metallic in nature, ceramic in nature, or polymeric in nature. Three-dimensional nanomaterials. Bulk nanomaterials are a material that are not confined to the nanoscale in any dimension. All the three dimensions are not in nanoscale. These materials thus characterized by having three arbitrary dimensions above 100 nanometer. Its three dimensions are above 100 nanometer. X-axis, Y-axis, Z-axis. These are above 100 nanometer, so that is why these are called 3D nanomaterials. Material possesses a nanocrystalline structure or involve the presence of features at the nanoscales. The materials which are not nano, not their dimensions are not in their all three dimensions are not in nanoscale range, but they may possess nanoparticles in the form of composite or nanorods or nanowires or nanofibers embedded in the matrix in the form of composites. So the material as a whole is three-dimensional, but there are nanoparticles inside the three-dimensional material. So that material is called three-dimensional nanomaterial. So there are some features at the nanoscale inside this three-dimensional nanomaterial. In terms of nanocrystalline structure, bulk nanomaterial can be composed of multiple arrangement of nano-sized crystals. So nano-sized crystals are present there, but they are arranged in a multiple manner, and the material as a whole is 3D, most typically in different orientations. Nanomaterials are embedded in different orientation and in as nano-sized crystals. With respect to the presence of features at the nanoscale, 3D nanomaterial can contain dispersion of nanoparticles. So inside a 3D material, there may be dispersion of nanoparticles. 3D material is the matrix, and the nanoparticles as a reinforcement may be present and as a whole in form of composite. Nanoparticles in the composite, nanoparticles may be present, nanowires may be present, nanotubes may be present, and multi nanolayers may be present inside the matrix, and the matrix is 3D, but these nanomaterial reinforcement give characteristics of nanomaterial to their 3D material. Here is the example of the 3D nanomaterial matrix reinforced layer nano composite. Uh, Matrix material, which is a 3D material, it may be reinforced with nanoparticles. So this is a nanomaterial because it has the characteristics of nanomaterial, but it is 3D. Matrix reinforced with nanowires or nanotubes or nanowires may be present. Laminates in the form of layers may be present. The layers inside the material may be present. So as a whole, the material is 3D. But if we look at the each layer, the thickness of each layer will be in nanoscale. Sandwiches may be present. Sandwich in the form or nanocomposite may be in the form of sandwiches. The two layers of same composition, but the middle layer of different composition. These materials are formed of two or more material with very distinctive properties. This is about composite. Composites are made up of two or more materials. They have different properties that act synergistically to create properties that cannot be achieved by each single material alone. So when two materials of different properties are mixed together, they give a new property, and their new property cannot be achieved by any single material. The matrix of nanocomposites, which can be polymeric, metallic, ceramic. The matrix may be of three forms. Matrix may be polymer in nature, metallic in nature, or ceramic in nature. Has dimension larger than nanoscale. So the matrix has dimension greater than nanoscale. It is 3D material, while the reinforcing material is of nanoscale. These are either nanoparticles, nanotubes, nanowires,